Hello there, welcome back to the new lecture. So in this lecture we have to discuss car parking ventilation part 2. So after the end of this lecture you would be able to understand about the calculation for ducted system. So let's start. Now here you can see that how to design the ducted car parking ventilation system and how can we have to do the calculation for that. So here I have taken one question. So with the help of this question you can easily get that how we can design the ducted car parking ventilation system. So see what it is telling in question. A basement of length 40 feet, width 30 feet and height 15 feet. Find out exhaust air CFM, fresh air CFM, exhaust duct size, fresh air duct size and filter box sizing. This parameter we have to calculate. Okay, remember here exhaust air always we have to calculate in which unit? CFM, cubic feet per minute. Okay, because we are talking about in this calculation imperial unit. Okay, so you have to use feet. Okay, so see here in solution what detail is given in this question. So we know that to find out the exhaust air CFM, that we have a formula. If you remember, I have already discussed about that volume of space in meter cube into ACH, air changes per hour, divide by 1.7. Okay, so in that first of all we need volume of space, and if you remember here in question basement length width height is given, but remember the height width and length is given in which unit in question? Feet. So first of all we have to convert that feet in meter, then only you can put that value in this volume of space. So given that length how much it is given? 40 feet. So first of all we have to convert that feet into meter na? Because here we need volume of space in meter cube. So how to convert? We have to multiply by 0.3. So you get the value 12 meter. Now you can see width in question is given 30 feet. So to convert that feet in meter again we have to multiply by 0.3. So you get 9 meter, and height how much? 4.5 meter. Now how to calculate the volume? We know that volume of space is what? Length into width into height. So when you do the calculation now you get 486 meter cube volume. Okay, once you get the volume, so we know that for normal mode how much we have to maintain the ACH value. If you remember in previous session we have discussed about that. For normal mode always we have to take ACH 6. It means what? ACH is air changes per hour. It means in 1 hour we have to change the air 6 times. 6 times we have to change the air. Okay, to improve our indoor air quality. Okay, so formula is what now? Exhaust air CFM is equal to volume of space in meter cube into ACH divided by 1.7, and volume of space we have calculated, and for normal mode ACH we have to take 6. So you have to put all the value in this question. So finally when you put volume of space how much we get? 486, and into 6 divided by 1.7. So exhaust air CFM we get 1715.3. Okay, in CFM, cubic feet per minute. Now we have done exhaust air CFM, we have calculated that. Now I want to calculate the fresh air CFM. So how we can calculate the fresh air CFM? I have already told you in formula. To find out the fresh air CFM we have a formula that 70 to 85% of exhaust air CFM is our fresh air CFM. So you have to take between this range. So suppose I have taken 80%. So we have calculated exhaust air CFM how much? You can see in this image how much we get exhaust air CFM 1715.3. So take as a 80% of this exhaust air as a fresh air. So how can we take? Just see here. So to find out the fresh air CFM, see I have taken the value of exhaust air CFM 1715.3 into 0.8, 80% I have taken. Okay, so you get the value how much? Fresh air CFM 1372.24. It means that much amount of fresh air we have to supply into the basement. Okay, so we have done both. But remember, this calculation which you have calculated na, exhaust air CFM and fresh air CFM, is for normal mode. Okay, suppose if there is a fire mode, so for fire mode, ACH value how much we have to take? 12. Means in 1 hour we have to change 12 times air. Okay, now same formula we have to use to find out the exhaust air CFM. Volume of space in meter cube into ACH divided by 1.7. Volume of space we have already calculated, 486, into ACH value you have to take 12 divided by 1.7. So finally you will get the exhaust air CFM how much? 3430.6. And remember your one point, always remember everyone, while doing the duct size, always we have to take what, because duct size is totally depend on if you are doing the exhaust air duct size, so we have to take that exhaust air CFM, Q value is that much. So always duct size is always depend on fire mode. Okay, always we have to do the duct size for fire mode only. Okay, so that is why suppose if you are calculating the duct size, so we have to prefer what, suppose if you are doing the exhaust air duct size, so we have to take Q value, exhaust air flow rate value how much? 3430.3, 30.6. Now in case of fire mode, remember, okay, in case of normal mode we have to supply fresh air, but remember in case of fire mode, in car parking ventilation system, in case of fire mode we don't need to supply fresh air. Why? Because you know that, I think, for fire we need three parameter. What are that parameter? Oxygen, heat, fuel. If one of them are not present, fire will not occur. Okay, so if in suppose if there is a fire in basement and you are supplying oxygen, because if you supply the fresh air, it means you are supplying oxygen into the basement, it means your fire frequency, fire will increase. Okay, so that is why remember for fire mode we do not have to supply the fresh air. Okay, next thing, note, it is written here, in fire mode do not need give fresh air, do not need to give fresh air. Okay, now how to do the exhaust air duct size? See everyone, so for that I have told you we have to use what formula? Q is equal to AV, continuity equation. Here Q is what? Exhaust air CFM, and we have calculated how much exhaust air CFM? 30.6. And I have told you that always duct size we have to do always for fire mode only. Okay, so here for commercial, okay, Q value we know that 3430.6, but how much velocity we have to maintain? So velocity is totally depend on what, for which building you are designing. It is a public residential building, commercial or industrial. So suppose I am assuming I have a basement commercial building. Okay, so for commercial building, what velocity you have to maintain? You have to take 1000 to 1600 fpm. Between this range you have to take the velocity. Okay, now see Q value, we have to take 3430.6 CFM for fire mode only. Now put this two value, you will get the area. You can see here how we can get the area. Area is equal to Q upon V. Q value 3430.6, which you have calculated for fire mode, and velocity, suppose I have taken maximum velocity 1600 fpm. Okay, so we will get the area 2.14 square feet. So once we get the area, so you can easily size the duct. You know that we have a different shape of duct, rectangular, circular, square. So what type of duct you need, it is based on your requirement. Okay, so suppose if you find out, if you are doing the duct size for rectangular duct, how to find out the size of that duct? See everyone, so this is my rectangular duct. Okay, So how it's look like this. Here we have a length of this duct is L, and this is a width of this duct, okay, and here we have a height of that duct, okay, width, height, and this is a length. So our main target is what? We are finding out the size of duct na, this width and height. What is the width and height of this duct? So this is our main target. So area we have calculated, if you remember, 2.14 square feet. Now here you have to tell me that what is the area of rectangle. It is simple, width into height, okay. So area of rectangle is what? Width into height. So here you have to write down width into height is equal to 2.14. Now what you have to do, in case of rectangular duct, here we have to satisfy this ratio. Width by height is always greater than equal to 1 and always less than equal to 4. As per SMACNA, we have to satisfy this ratio, okay. It means suppose if you have taken your width value is coming something and height is coming something, when you do the ratio na, so your value will be between this 1 to 4, okay. Remember we have to satisfy, but this condition only for rectangular duct, okay. As per SMACNA we have to satisfy this ratio. So here height you have to assume, how much height you have to assume, and suppose if you are doing the live project, so on that time they will give you the height, that how much height you have to take for your services, for HVAC services, okay. So they will give you on that time, but here during calculation, here height you have to assume, and remember height you have to take as per that. If you calculate the ratio na, you will get the value between this, it will be greater or equal to 1 or less than equal to 4. So what height I have to assume? So see, suppose I have assuming let height of duct is 1.2. so if I have taken height 1.2, so we have to uh, this height value we have to place in this equation, which this equation we have calculated now, width into height. So once you put the value of this height in this equation, so you will get the width also. So finally when you put the height in this equation na, so you will get the width. See, 2.14 divide by, because height will come this bottom side, so divide by 1.2, finally you will get the width of duct, how much? 1.78 feet. So convert this feet in mm. So how to convert? We have a conversion formula. 1 feet is equal to how many mm? 304.8 mm, okay. So that is why here what I have done, width we get 1.78 feet. If you multiply this this product 304.8, so you will get the value in mm. So here when I multiply, I will get 542.54. So it is around 550 mm. And similarly I have done for height, okay. So when we convert the height in feet in mm, so you will get the how much height? 350. Now what you have to do, just take the ratio width divide by h. When you take the ratio na, the value is coming between this range 1 to 4. It means your condition is satisfied, you can take this value, it is a correct, okay. So finally we have calculated the exhaust air duct size, how much? 550 width and 350 height, okay. In this way we have to do the calculation for rectangular duct. Now suppose if you are using round duct, so for round duct what we have to do? So for round duct we have to calculate the diameter of duct. So how to calculate the diameter? Simple. You know that the area we have calculated 2.14 square feet. Area of circle is what? Pi by 4 d square, simple, okay. So we need to find out the diameter. So when you simplify na, you will get the diameter around 1.65 feet. And to convert feet in millimeter, you have to multiply by this factor 304.8. So you get the value around 500 mm, okay. So in this way we have to, if you are selected round duct, so in this way we have to calculate the diameter of that duct. Now suppose if you have taken if you are doing the duct sizing for square duct, if your duct shape is square, so for that how you can calculate the size of that duct? Simple. Here you can see, here we have one image, and in that image I have taken a square duct. The length of that duct I have taken is capital L, and side of that duct is what? For square we have same side, all sides are same, so small a I have taken. So area, how much we have calculated? 2.14 square feet. Okay, area of square is what? A square. Simple. If side you have taken small a, so area of square duct a square. So finally you will get the small a value 450 mm. Okay, so it means what? Exhaust air duct size is how much? We have calculated for square duct 450 mm by 450 mm. Okay, so in this way we have to find out the exhaust air CFM. Based which type of shape you have selected, based on that shape you will get the exhaust air duct size. Okay, now we have to calculate the fresh air duct. We have to do the fresh air duct size. So for fresh air duct size, remember fresh air only we have to supply for normal mode. Okay, and we have calculated how much, I will show you. So we have to use same formula, Q is equal to AB, which we have used in exhaust air duct sizing. Here for commercial, what velocity we have to maintain? 1000 to 1600 fpm. Suppose I have taken 1600 fpm. Okay, because we are designing for commercial building, so velocity I have taken 1600 fpm. Okay, and Q value we have calculated in normal mode, how much? Fresh air 1372.24 cfm. So to find out the area, you can easily get the area. So suppose first of all I am doing the sizing for rectangular duct. So if it is a rectangular duct, so we know that you can see in this image, here we have a width of this duct, height and length of that duct. So how to calculate the area? Same, we have to use this formula. So you will get the area how much? 0.86 square feet. Now tell me, for rectangular, what is the area of rectangular? Width into height. Simple, you have to put that value, width into height. Now then remember, in case of rectangular duct we have to satisfy that ratio. What ratio? We have one condition as per spec na, we have to satisfy this ratio. Width upon height is always greater and equal to 1 or less than equal to 4. 1:4 ratio, this is the aspect ratio. Okay, we have to satisfy this aspect ratio. So see, so here we have to assume the height of that duct. So you will get the finally. So suppose here I have assuming height of duct is 0.8 feet. So put this value in that equation which we have calculated now, width into h into area. When you put, you will get the width of duct 1.07 feet. Now convert this feet into mm. So when you convert now, you will get width of duct 350 mm and height how much? 250 mm. Then just divide both of them, 350 divided by 250. So you will get a value around 1 point something. It means you are under that ratio now, 1:4 ratio. So condition is satisfied. It means the value which we have selected, height which we have taken, it is right. So width or height of this duct is given here. Okay, so in this way you have to do the calculation. Same way finally we get how much? Exhaust air duct size for fresh air. So not exhaust air here, remember here we get the fresh air duct size 350 into 250 mm. Okay, now note here, similar we have to do for round duct and square duct size. Okay, which we have done now for exhaust air. Same way we have to do for round and square duct size. So in this way we have to find out the exhaust air duct size, fresh air duct size manually. Okay, and we have a software also, MEP duct sizer software. With the help of that software also you will do the duct sizing to reduce your time. Now the next last, what we have to find out? We have to find out the filter box sizing, and I have already told you why we are using filter box. because suppose if you are designing for normal mode, we have to give the fresh air also into the basement. So fresh air we are taking from outside, so directly you cannot take that air and supply to the basement. We have to install the filter box first. We have to filter that air, then only you will supply the air to the basement. Okay, so how to do the size, how to calculate the sizing of that filter box? So for that, same formula, Q is equal to AV continuity equation we have to use, but here remember the velocity is different. What velocity we have to take? 250 by to 350 fpm. Okay, that much of velocity we have to take. So here I have taken 300 fpm velocity, and Q value, fresh air CFM we have calculated na, 1372.24. Divide both of them, so finally you will get the area of that mesh. How much? 4.57. Okay, so area of filter we get 4.57 square feet. Now what we have to do, you can see here one image is there. This is a filter box. So suppose in filters box generally we have three sides, means air will intake from three side. This from front side. Okay, yeah, this is our filter, so air will intake from front side, then here through this side and through this side. Then the side which is back side, we have to connect the duct, okay, which is going into the basement. So air will intake from three side. So here you can see, so air intake from three sides. So can you tell me the each mesh or each filter area is how much? So if the total area we have calculated 4.57 square feet, total area of that filter mesh we have calculated 4.57. Now air intake from three sides, so therefore each mesh area or each filter area we get 1.52 square feet, each filter area. And remember here the mesh or the filter which we have to install in the filter box, here how much this gap we have to maintain? 1 inch. Okay, it is the standard gap space we have to maintain. Okay, 1 inch we have to maintain the gap during the placement of filter into the filter box. Okay, now here we have calculated each mesh area 1.52 square feet. Okay, now what you have to do, once you will get the each mesh area, so suppose if suppose my mesh or my filter, mesh or filter both are same. For a square mesh we know that if side I have taken for mesh, suppose my mesh side is small a, so for a square what is the area of mesh? A square is equal to 1.52. so finally you will get the side of that square mesh 400 mm. Okay, so this is the size of your filter or your mesh, 400 mm width, 400 mm height, because all sides are equal. Now okay, we get the mesh size. Now we have to calculate the filter box size. So to calculate the filter box size, see, if once you will get the mesh size 400 mm, I have already told you that what space we have to maintain during the placement of mesh into the filter box, 1 inch standard gap for both sides. So you have to add both 400 plus 25 plus 25, so you will get 450 mm length, 450 mm width, 450 mm height of that filter box. Okay, so in this way we have to do the calculation. Okay, I hope all of you understood about this calculation.